you will find that I think one of you guys, when you have the privilege of flying in an aircraft, sit near a window behind the flaps. Okay, so you will see what happens, how it comes back. It comes back and it goes down. Now the one that we have on the 172 is a semi sort of a fowler, because the slots are there. It goes into the wing and then it comes out. So it's a smaller increase in area. Larger aircrafts, because of the larger wing and the weight, you need to increase more. And some, as you say, the flap, the wing area like this, yeah. If this is the wing, you have the ailerons, which gives you directional control. In some cases, the flaps actually extend all the way up to the whole length of the wing, because that gives you extra, surface area, and it also reduces the speed. You see, for example, a jet aircraft coming into land is coming in at almost, it reduces itself from 400 miles an hour to almost 250. On approach, it's doing about 250 miles an hour. And when it actually lands, it's about 80 miles an hour. So you can see, the only way he can reduce speed is because he has to increase the angle of attack, correct?
Yes.
The angle of attack. So as that's why you find the aircraft when they come in, you have that attitude, yeah? Because the flaps are down, the speeds are lower, and he's coming on a glide angle into the threshold to land on the runway. Okay? Any other type of flap? You said 4, you got 2 now, so yeah. Split flap. Split? So it doesn't move, it's just on the bottom half of the aircraft. Yes, that's right. So that is only attached to the bottom of the surface here. So what happens is, then you have the pivot point. If this is the trailing edge of the wing, the flap in its reclined position is sitting there. So when it comes down like this. So it is not increasing the surface area. It is just increasing the angle of attack. But these are they are not very common now. Because now everywhere they want to increase the surface area, which gives you. This is an earlier model. Very old aircrafts had split flaps. Yeah, it has evolved from the split flap to the trailing edge flap. So they noticed that if they move the hinge point to the rear of the wing, you are increasing the wing surface. This is not increasing the wing surface. You understand? And then again it evolved again, like I told you, in the Fowler flap, the airflow is just going down like this, correct? So what they did is they put they made this small bit of it will come there, the second half will come on there. It's all about on your flap tracks that guide so the airflow at under the wing actually speeds up and pushes the transition point rearwards, which gives you the extra lift. You understand? So the movement of the transition point is very important, okay? Or relative to the airflow. Okay. When you are in cruise, it's in the front, correct?
Yeah.
And as you slow down, it begins to move back. And when the transition point actually comes out of your rear of the wing, that is when the wing collapses and you stall, okay? All right. So there was one more left now. Which one is that? Split, Fowler, trailing edge.
Yeah. Also have Kruger, the
Kruger flap.
Yeah, flap.
Oh, I haven't heard about that.
Oh, it's more advanced.
So
I think it's used in modern it's used in modern aircrafts.
Marine. Modern aircraft. Oh, Kruger crafts. Maybe it's the design, but what is the principle then?
Yeah, it's like 2 flaps, but then they split between themselves.
Yeah, but that's what I just explained to you here. This is the Fowler principle.
Okay.
So probably they called a Kruger. I did my class 50 years ago. Okay. Yeah. So it's a Fowler principle, which means that you have another split here, another one comes down. In fact, some of the larger aircraft might even have, cargo aircrafts, you need heavy lift because it's carrying a lot of cargo. so weight is much heavier, and that's why even cargo aircraft will have a camber, the higher camber, because that gives you, there's not so much of a, bigger the camber, the higher the airflow going through it. Yeah. Okay. Chord. It also depends on your chord of the wing. This is all design factors. For maintenance, you don't need all this.
So the flaps are named according to their design.
Huh?
The flaps are named according to their design. Flaps.
Oh.
They are named according to their design.
Yeah, you have the split flap. Everybody, as you say, if somebody comes up with a new technology, they give it a different name.
So how about the flaperoid? A combination of the aileron and the flaps.
Okay, aileron and flaps is okay. Let me explain. What you have is Horton stall. It's called on small aircrafts. What happens is that when you select the flap, also your aileron goes down. Okay? Do you understand what I'm saying?
There are some aircrafts that have a combination of only.
Yeah, so it pulls the aileron down completely 40 degrees of flap. They will use depending on the load. Sometimes you see, if you have light load, you don't need to use the flap. You can do a flapless training takeoff. If you have higher loads on the wing, then you can reduce it to about 10 degrees. Yeah, so it will give you that extra bit of on takeoff. You'll be able to, and also remember when at times what happens is when you're taking off, you have to clear the obstacle in front of your runway. So if you have some mountains ahead of you and you want to go up suddenly, then you might have to use flaps. You see, because then of course what happens there is that you are using full thrust. That means your speed is compensating for the angle of attack. You understand? Okay, and at the same time, the flap gives you that extra lift, so you have a quicker takeoff, or a steeper takeoff. Yeah. Flaperons, that's what is. So what happens is the Horton stall on the light aircraft is what happens is when you select the flaps, you do have aileron control, but for landing you are not turning. You understand? For landing, you want to keep yourself steady and straight along the runway. So what happens is when the flaps go down, the ailerons also go down to a certain extent. It doesn't lose its movement of the of control, but it goes down. So when it goes down, that angle of attack increases. So you have a lower speed. Yeah, for landing. Yeah. Basically for landing, you use it. Everything, the flaps are used mainly. The main function is for landing. Okay, any other surfaces now?
Ailerons.
Aileron, okay, so that gives you the control.
It gives you control during banking rolling.
Sorry?
During rolling.
Rolling, yeah. So what is control of what axis?
The yoke.
No,
What axis?
Okay, that's the vertical.
No.
Horizontal.
long.
Longitudinal.
Yeah.
You're going longitudinally, moving this. That's all it does, okay? Right? Okay. So ailerons. And ailerons, any other surfaces that are attached to the aileron?
Spoilers.
Spoilers.
What?
Spoilers.
Spoilers. On the ailerons.
Tabs.
Tabs. Yeah, tabs. Oh, yeah, trim tab. Well done. That's the answer. Trim tab. Why do you use a trim tab?
I think for stability.
Huh?
Stability.
Stability.
Yeah,
No. It's not stability. Anybody else? Hello? Nobody's paying attention.
Increase the pilot's control.
Huh?
Increase the pilot's control.
Yeah, it assists in moving the control surfaces. Because you see, what happens is that it moves in the opposite direction of the flap of the control surface. Okay? So what it does is it moves into the airflow, so it assists this is the question. Earlier aircrafts, when they were designed, it was all pulleys and cables, yeah. So, and on larger aircraft, larger surfaces, because of the forward airs, if your airspeed is, say you're doing 200-300 miles an hour, and you were to move your controls, you would need assistance. Do you understand? So what happens is that if you move the flap down, the trim tab moves up. So the tab actually, the airflow hits the tab and assists in pushing it down. Yeah. So it always moves in the opposite direction to the control. Your trim tab always moves. That is to assist in moving the control surfaces. And there are 2 or 3 types of trim tabs, yes? There are spring-loaded trim tabs also, that once it does the initial movement, it aligns itself because of the springs that are there. Yeah, so it brings it back again in line with the control surfaces.
Yeah.
Okay, so you can have an elevator trim tab, you have a rudder trim tab, and you have an aileron trim tab. Flaps don't have trim tabs. Huh? So it assists in moving because you get the feel also. You understand? But otherwise, it would be pretty. If the faster the aircraft, it would be more difficult for you because you will have resistance, from the airflow. So larger surfaces, as you say, to move it down against the airflow, you need some sort of an assistance. So that moves in the opposite direction, pushes the airflow and assists the movement of the control surfaces. So what is the function of the elevators?
Louder.
Control. Yeah, you see, I told you, we said aileron was control over your longitudinal axis. So what is the elevator do? Vertical pitch. Huh? Lateral axis. No, that's the vertical axis. Vertical. Because when you move your elevator, your nose is going up and down. So that's the movement. So lateral axis, you're right. Along your lateral axis, yes. So it moves up and down. And the rudder gives you directional control. So that is along the vertical. So rudder, when you kick the rudder moves left and the aircraft comes right. Okay. And basically what happens is when they are rolling the aircraft, they use a combination of aileron and rudder to actually roll. That's all different technique of doing it. Okay. Inspection of control system components. Okay, basically aircraft controls, as you say, they are always, you have bell cranks. You should be able to draw a simple aileron system. Yeah. Okay. Which means that when you move your control left, the left aileron goes up, the right goes down. So if did you show them a diagram of what an aileron, simple aileron control is? How it is achieved?
I just drew it.
Yeah, so you must know how it is, yeah? And you have the control column, because you have the movement of your control, that coming at the same time from there. The winglets do not have an angle of attack. They are basically more or less straight. So you have an aerofoil section with high speed air going through it. So what happens, it still maintains the airflow. So it finds it very difficult from underneath the wing to come. As it begins to come to the top, it speeds along with the winglet pulling it down. It also improves the efficiency of the aircraft.
Yeah.
They say that it saves a lot of fuel.
A lot of work.
Because of drag. As you say, if you're drag, you're slower. You're slower, you consume more fuel. If you're faster, you consume less fuel. Yeah? It's a simple common sense. Duplicate inspection. Yeah, whenever you do a control surface, it's a primary surface. Because if something goes wrong in the control surfaces, then the whole aircraft is in danger. Yes. So what happens is that one engineer does the rigging of the component of the system. Then an independent guy goes and he checks the entire system to see that he has done, which means he has to check the rigging, he has to check the tensions, he has to check the travels, he has to check the locking devices are all in place, and attachment, of course, of your control surfaces. They are properly locked, all the bolts and nuts are properly locked, wire locking wherever is required, wherever there are lock nuts, they are in place, turnbuckles are locked, what else is there? And the correct tension, of course. Your pins, attachment points for your control surfaces are all properly in place, and split pin. Control surfaces always have split pins because that's a better safety. They do not have lock nuts, more or less. They are attached, bell crank attachment points have castle nuts with split pins in it. Yeah. You know what I mean by castle nut, yes? Not with slot on it, yeah? So you can, the hole in the bolt goes through the bolt and into the slot, and then you bend the split pin so it keeps it in place. Okay, persons who are authorized. In the old system, the regulations here required an independent engineer to come and certify. But since our civil aviation is a bit lazy, they did a copy paste and they forgot about duplicate inspection. Okay? Duplicate inspection is very important because, as I told you, safety of it. But still, as in the regulation, it doesn't tell you anything about duplicate inspections. Which means that the companies locally we have a principle here that whenever a control surface is disturbed, there are two people who have to go through it to make sure everything is in place. Yeah? Control systems, fuel systems, and ignition systems are very important. Okay, so we always have duplicate, and brakes also. Sometimes people, brakes either they over tighten and things like that. And of your wheels, we make sure that the wheels are properly torqued with a nut and there's a split pin in place. So one guy finishes, another guy checks to see it is being done. It's a safe way of doing things, but as you say, most of the time, it's also how the wheels should lie. Yeah, you've seen it on TV. You've seen Formula One cars. Yeah, you see there is a camber in there. Yeah.
Yeah.
So at certain speeds, that compensates for your force on the aircraft up and down. Yeah. So in its normal position, they give you figures. Cessna gives you that you should have a certain amount of outboard temper. So when you are fully loaded, the spring comes, the legs come vertical. Yeah. So you have a outward, and then you come back into normal. Guards and covers. Cables. Cables have guards on them, yeah? So that when there is a change of direction, it is attached where the pulley is, so that the cable cannot jump off from the pulley. So those guards, God, no, I have to show you some. I'll show you some. On the yellow aircraft, when we removed the pulleys, there were guards on it. Did anybody notice that?
Yeah.
Yeah. So that guard stops you so that the cable cannot jump out from the pulley at any time. Okay? Because the distance is very little, so it stops it. So that's the function of the guards. Fairly easily explained, yeah. And covers. Covers for what?
Usually there is a cover, especially on the yellow aircraft, there is this cover on the top where the turnbuckle was. So I think maybe we can take a look at that.
Cover.
Yeah. It's in the CIP.
The yellow circular, the one you are fixing from the side.
Oh. No. Where the sprockets are also, you have the sprocket guards also, yeah? So on the sprocket guards, there is a metal piece which stops the sprocket from the chain from jumping out of yours. On the bicycle, like you have on the bicycle, yeah? When you're riding, you don't want the chain to fall out. There's a guard on it. So that stops the chain. If it's too loose, it can jump off. Yeah. So that's the guard they're talking about. Is that the one you're talking about?
Yes, sir.
And on the sprockets also there are little lugs attached to it, which means you have a primary stop on the control surface, which means on the bell crank you hit a stop on the slot. When the bell crank moves, there is a bolting going through it, and it up and down, so it hits that stop. Yeah, that's the primary stop. Then sometimes you on certain controls you have secondary stop, which means that especially on the elevators, you don't want your elevator, because you can actually push your elevators further up. So there are stops at the back of the elevator, so the movement when it reaches you there. But if you force it a little bit more, there is a secondary stop in the front where it touches another secondary stop. Yeah. So you have primary stops and secondary stops. So the function you should see where they are. Yeah? Yeah, now also because they are especially the spring, the red aircraft it's a steel leg and it's very heavy. They come up with new titanium spring undercarriages, which are much lighter, much stronger, and much more resistant to corrosion. But they are about 10 times more expensive. Rubber cords and maintenance. So on the Super Cub we have rubber cords, which are bungee cords. So what happens is there is a shock absorber. So when it hits, the bungee cords extend and then they bring the back. But then that movement can be very erratic. So there is a shock absorber. So the shock absorber does the same thing. There is a piston and a hydraulic unit which moves in and out. Let me see if I can make you some. These are for old age.
lies in the straight position.
Trunnion. Yeah, the upper part is called the trunnion. Yeah. So your trunnion is main undercarriage is also larger aircraft. You see, for example. You see that large aircraft? Then you see the undercarriage is got the base on the top, and then the top bit is the oleo trunnion. It's the trunnion, they call it the trunnion, where the oleo goes up and down. Yeah? That is the part of the top. Yeah, see that stops the wheel from moving around. Yeah. So you see that here. Because the audio is totally free. Because you see, top half is formed, but the piston inside can move on either side. They won't stop there. Right, yeah. Breaking up vortices, yeah. So the speeding of, because this is a convergent depth, yeah. So upper surface is, so the airflow speeds up, moves your transition point to the back. There's a screw jack here which operates it, yeah? It operates the beltran. The screw jack operates the beltran. And then when it's spinning, it's into vertical. The control is more or less in line. So everything is in line, yeah? You see that. Sometimes you have that little bit of good. And the wing, you see this is a design factor to stop your induced drag. Yeah? At the same time, you don't want the airflow to go over the top. So you see it's wider at the back, narrower at the front. Because the vortices start here at the back, more or less. It starts at the back, not in the front. Okay? This is where the main leak of air from the bottom goes to the top. Was to roll to the left. So in order to roll to the left now, and you kick your left rudder, which is the position it is in at the moment. So also at the same time, your aircraft will move along the vertical axis. So it will now roll like this. Okay? So you're turning at the same time. You understand? That's for your just your turn, yeah? You can't just turn on the aileron. People turn with the rudder also. It assists you in making it simpler. You can turn if you want to, but you'll have to use a lot of force. You understand? Because it's also giving you directional control. So as your aircraft is just beginning to turn and you're getting turn, you see? Do you understand? It gives you that angle and you'll be able to turn. Okay.
I forgot it today. Why? Was in a hurry.
I'm not supposed to be around this house like that.
Let me just say that I need to have it so that I can gym.
You can what?
But let me say that I need to have it.
What the people?
I forgot.
I'm not supposed to hold it. It's like small thing. You see all your fellows are putting on the flex there.
You can see the rudder is one stop. It's like a primary stop. You see that? When it goes to one side, it stops it there. Yeah? You cannot go beyond that. Beyond that. It won't go beyond it. Huh? I mean, what do you... Yeah, because if this goes beyond this, it will interfere with the elevator system. The airline stops are right here.
This is your stop.
Up movement is less, down movement is more. That's your printer, yeah? What do you call it? It needs a system. That's what I'm trying to say, it speeds. And sometimes you don't need, if your aircraft is trimmed properly, what they do is they move the trim tab to get the finer movements. Yeah? So if you want nose down, the control surface will move down. Yeah? Okay? And then there's a wheel there. So you move it here, nose up, because when you're coming into land, you need to bring your nose up. You can't adjust it. The finer movements are done on the trim tab. So by moving the trim tab, it moves your elevator automatically. You see? Yeah, same thing. Fine movements are done by trim tabs. Yeah. So they constantly don't have to keep on doing this on the control surface. Yeah. So if you want to go down, You just move the trim tab to nose down. It will move in the opposite direction. It will do that fine movement. You see, the fine adjustments are done by trim tabs.
Said immediately immediately move the elevator, the trim tab also moves the opposite direction.
No, the trim tab is in the neutral position. It depends on how you want to move it. No, your trim tab is usually in the neutral position. Only when you're in the flight, now you want to go nose down. You don't have to keep on. Say they ask you to say you are at 5,000 feet, and they say start descending at 500 feet per minute. Yeah. So for 500 feet per minute, if you start to move your control surface, it might go more than that. Whereas if you do it with a trim, it gives you the finer movement. You see. Yeah. Octane value. Do you know what the octane value of fuel is? That's what you need to know. Because they add lead to the fuel to stop detonation. If you have a low octane slats are on the leading edges. Again, the same thing. As you go to a higher angle of attack, because of the higher angle of attack, the slats open up. They open up and they come out, and they let the airflow. Again, it's an aerofoil section, so it lets the it speeds the aerofoil. The airflow speeds over the top surface. At the same time, the slat, the surface is slightly up, so you can improve your angle of attack. Lowers your speed. They're automatic. Some of them just go up because of the airflow. It just springs up, and then, if you straighten it out, it'll go back into it. It depends on the relative airflow of the air. If your aircraft is in this position, then the slats, because the airflow is coming down, then it pulls the slat up. So it pulls it up. It's an aerofoil section, so the airflow speeds faster, moves the transition back. So you can do lower speed approach on the runway. Retractable undercarriage now. How can I say it? Retractable undercarriage is the same. You have the oleos, and by linkage, you have linkages with hydraulic rams and linkage. It moves the undercarriage up and down. So you have a hydraulic system, you can have a pneumatic system. Pneumatic, again, same thing. It has hydraulic rams moving the undercarriage up and down. Yeah? And then there are all the other three components that go with it. So you have a control valve. The control valve serves the fluid for the ram to extend. Okay? So when it extends, the fluid on the other side goes back to the reservoir. Right? Through the control valve. Yeah? Okay? And when you select up, the fluid is directed to one side of the ram, it goes up again. And the other side fluid goes through the control valve into your reservoir. Then you have other smaller items like, non-return valves. You have special valves which, for example, the nose leg. When you're selecting the nose leg down, there is a restrictive. So what happens is, because when you're applying 2,000 pounds of pressure, a normal operating hydraulic pressure is around 2,000 pounds. So 2,000 pounds, suddenly you put on a piston ram, it will snap itself. Yeah? So there is a restrictive valve. So what happens is the fluid that goes in for a down selection begins to go down slowly. Okay? So there on larger, depending on the weight of your undercarriage. On large aircraft, the undercarriages are as big as, they are higher like this, from 8 to 10 feet. Yeah? So, and they are very heavy. So when you need to move, let them move slowly up and down. You don't want the movement to be jerky or fast, otherwise it can go and damage things. Yeah? So you have up lock also. So when the undercarriage comes into up position, there is a lock which locks it, so that when the hydraulic the pump stops, when it has reached its position, the micro switch is off the pump. Yeah. So then it's kept in the lock position, and then when you select down, the hydraulic lock opens and brings the undercarriage down. And in the down position, you have the over center lock. Yeah. Where if you have 2 points which are moving up and down, if it goes to over center, then it's a safe position. It will never collapse. I explained that to you. I explained that principle to them. It's very important. Yeah? You want everybody to stop flying?
No, you can use 80, grade 80.
No, you can't use grade 80 because this is a high compression engine. You know?
Is it because of the pressure? Or might because of the
No.
efficiency?
It's compression. You see the compression, high powered. If you have a 100 horsepower engine, a 500 horsepower engine. A 500 horsepower engine is producing a lot of heat. Giving out a lot of heat. So if you have in your combustion chamber or on the cylinder head, if you have a point which is glowed because of the heat, because it constantly is combusting and going through. So if there is like even a slightest glow point and a high compression engine, you will have detonation. As soon as the fuel comes in, it will explode. Yeah, that's what happens. You know, when you have fumes and you put effort, you will find out you'll be going straight to like that. So the leg stops the what you call the high flash point, reduces the flash point. Because it's the flash that causes the explosion. The slightest spark, even a spark, if you have fumes, it will explode straight away. Because that is more volatile than actually burning something. You see, you try to burn kerosene and it's wet, it won't. Yeah? But if it's sitting and there are fumes and you try to do it immediately, you hear that. Spring steel is, you see, you take ordinary steel and you add all the different metals in it to make that spring in it. So same thing with Aeroquest. We add copper and what else do we add? About that, one is copper. When you add copper, it becomes more springy. It is able to resist. If you take ordinary aluminum sheet, you will be able to bend it with your hand and crack it. Yes? When you add copper to it, it becomes more springy. It becomes and it's stronger. So it's all about strength. Because undercarriage legs, you see, it flexes all the time. So you need the spring. If it's rigid, then it will damage the rest of the airplane. You see, if it doesn't take the impact when it lands, if it doesn't go up, it will pull up. This is somebody hits you in the shoulder, if you hold this and